All right, well, thanks everyone for joining us today on Second Gear's Tech Talk Tuesday. So you've met our speakers. Here today we have Holly Davis, CEO of Complement, Jason Claybrook, VP of Strategy, Business Development, and Marketing from Aura Wireless. And then you also have Leslie Zaks, Flight Business Development from Second Gear. So today we have a great presentation from them. It's on how to extend your campus network to the community for remote learning using the CARES Act.
Thank you very much. I appreciate that, Eleanor. So hi, everyone. So we really appreciate that you're joining us today. I want to take a quick second and kind of let you know who we are, which will definitely help you understand our perspective and what we bring to the conversation that we will have today. So on the call with us is Jason Claybrook. So Jason Claybrook comes to us from Aura Wireless. Jason has brings a lot of experience. So he has 23 years in marketing and business development and operations. And one of the things that's really cool is he's very good at strategy, but also really trying to find innovative ways to go to market and to help the consumer. So today with our audience that we're speaking to, we're going to be using a lot of his experience to talk about his product, Aura Wireless, and the Apogee antenna, and how that actually can benefit and help you as the customer, and especially speaking directly in the K-12 environment. So that also brings us to who I am. So I'm Holly Davis with Complement, and what we do is help in assisting companies that manufacture or resell technology to help them sell to the government. So we have a lot of experience at Complement in helping understand innovative ways that you can actually find a solution to meet how customers' need. And what we're going to talk about today is really what's going on in the homework gap. And that is why Second Gear asked us to join them on the call and take our expertise. I have worked with K-12 since 1997, so aging myself just a bit there. And in that time that I have worked with schools, and also the E-rate program, one of the things that we find that has been a problem is the homework gap. Now, why are we talking about this today, and what is important on why we're talking about this today is that we've had some very interesting times, right, with COVID and also with dealing with the way that it's affected the classroom. So now that we've had this spring a rush to everybody can't be in the classroom, everybody has to go home, IT departments having to determine how do I help make sure that the classroom can still function, but the classroom is no longer inside our infrastructure, inside our classrooms and our campus, where we actually provide the things that they need to do that e-learning and have that e-learning experience and environment, and that interaction and collaboration with the parents, the faculty, the teachers. So the challenge that we have with the COVID situation and the pandemic and having it create this environment where now you have to have remote learning. And that remote learning environment is not easy, especially if you have a large percentage of our students in America still do not have internet connectivity. So it's a challenge. And I understand that a lot of you are trying to make that decision and the right decision on how you go about solving that challenge. There's not one community in this country or within the U.S. territories that does not have a challenging or underutilized or properly, economically challenged communities where we properly have provided the right connectivity to those homes. The homework gap isn't something that just started. And that's why I find it very interesting that now we're actually seeing the government step up and realize students aren't going to probably be going back to school the way that we knew before. And in fact, some schools and states are talking about them going back to school in July. With students going back in July, and we're now here in June, what is that going to look like, right? And what have you done already as an IT administrator or superintendent of your schools? What have you done to make the right decisions to make sure that every student has that equitable learning experience? That means everyone. That's the reason No Child Left Behind was created. And it's why we have to really solve this once and for all. And we can't just put a Band-Aid on it. So what do I mean by a Band-Aid? So one of the things that the way students have been able to learn or have that homework situation at home without having internet connectivity is mom or dad would actually have to take their child or student to where they could get free Wi-Fi, whether it be a McDonald's or a Starbucks or the library, or those after-school programs that actually funded and paid for these solutions. So it's very challenging, especially the strain that it puts on that family to have to figure out a way for that child to have that internet connectivity. Think about it even too in an environment where the child has to be dropped off at the library or at that campus. Well, the campus is closed. What about security for the child? Why they're there having to sit outside that building to just be connected, to have that opportunity to learn. So these are those challenges that have to be solved. One of the great things that we see happening today with this homework gap and all the different funds that are being put at this problem to solve it is that we're going to solve it. And you are going to be given the tools and the funding to help you solve it. And not just through E-rate. So one of the things I'm going to talk to you about is some of the funding mechanisms at the end of our presentation today on how you can go and get money to help you solve those needs and really finally rip off the Band-Aid and put an actual solution. And let's help everyone to solve the homework gap in your community. So another piece of that too, and I will touch on this more at the end as well, is that one-to-one device connectivity. So there's a lot of ways that we can get really creative and innovative on really how do we solve this? How do we have an environment where a student can be in their home or outside their home and in that safe zone from that family unit and having some way to watch their child while they're doing their schoolwork and having to have that remote learning classroom environment? What are some ways that we could actually provide technology that would actually extend that network within that campus out to the community and to the home? And I know you've probably looked at and are thinking about some innovative ways that you could do that. But what we wanted to do today with the assistance of Second Gear is bring you an actual solution that can help you with this. And I'm going to actually hand this over here in just a second to Jason to give us more information on one of these really cool and innovative ways to solve this homework gap. And one of the things that we're going to talk about, for instance, what about those assets that are just sitting there not being utilized? We're talking about maybe a school bus. What if you were able to put a wireless access point in a school bus, take that school bus and put an antenna that could extend that connectivity with an array, a 360 array antenna that could get 10 plus acres covered. I'm serious, 10 plus acres can be covered by having a school bus go to a community. And one thing Jason's going to talk to you about this really cool solution is that he's going to explain to you not only how does it provide that type of community to the students, but some ways that it's going to be cost effective, more cost effective than having to manage the tablets, the laptops, and an air card or 5G or some of these other type of solutions that you have to manage another device, another asset that's on your network. So think about the security and all the other problems and concerns that come into play when you're having to extend the classroom and have more assets to manage. What if you could just take your internal network and communicate, send it out to the community via one of your school buses, or maybe some other community assets like the library. So with that, I want to hand it over to Jason to talk about this great new technology and how we can actually help you extend your network into the community. Hi, Jason.
Hey there. Thanks, Holly. So I have control of this thing, or?
Actually, if you say next, I'll move it forward for you.
Okay, fantastic. So thanks for that introduction. So yeah, I'm from Aura Wireless, running strategy, business development, marketing, and what we'll talk about today is our Apogee platform. So a lot of people, especially schools, school IT administrators, they're very familiar with Wi-Fi. They've dealt with a lot of Wi-Fi problems. on their campuses over the last 10 plus years. There's been a lot of great innovation in the Wi-Fi space here, even recently with Wi-Fi 6 or 802.11ax coming out. But there's always been limitations with Wi-Fi, namely how far that signal can travel. And whenever you're trying to cover large areas, you have to usually deploy a lot of access points, a lot of interference. You get a really dirty, nasty RF signal that really takes away from the client experience or the user experience. In this case, the student or the faculty member or teacher's experience and how effective they can be in on that campus network. And with COVID and some other forces at play, administrators now have to deal with the fact that their students aren't all in the classroom and that the network, the infrastructure that's needed to be provided to students for that equitable learning experience doesn't just exist in the classroom or in the gym or in the cafeteria. And it's got to make its way to the parking lot and beyond. So what we have at Aura Wireless is what we call Apogee, which is it is the first of its kind software-defined antenna platform. Most of the time when you see a Wi-Fi, actually all the time whenever you see a Wi-Fi antenna platform, those things are fairly static. There's not a lot of intelligence. It's going to apply some level of gain in a direction, 30, 60, 90 degree beam width, maybe 120 degree beam width, or 360. And that's all it's really going to do. We've added a lot more intelligence because we learned initially as a service provider that what the world really needed was a smarter antenna solution for unlicensed networks. So what we've created is effectively, you see the image there on your screen, in this 22-inch tall cylinder, it's 12 inches in diameter, is effectively 4 panel antennas that are connected by a common switching fabric so that they can work in unison or in isolation of one another. And what that allows us to deliver is an antenna platform that can be point to point, it can be point to multi-point. It has a lot of flexibility, and it's how you deploy polarity, and we'll get into that a little bit more. And this gives you a great deal of flexibility so that you don't have to go and get on site and figure out what kind of antenna I need. You can software define that antenna and software define your coverage ranges. And there's a lot of great secondary, tertiary benefits to that. Let's go to the next slide, Holly. So with Apogee, one thing that's really important to articulate right off the bat is this thing is cloud managed. It has a multi-tenanted, so that means that anybody that's logging into it, that's one of our customers, they only see their antennas in their network. But it has a multi-tenanted cloud management platform so that once the antenna gets an IP address and it's connected onto the network, all the administration is remote. Where we have a built-in compass, it's going to help us find true north because we have a sectorized design. Quadrants, those 4 panels I was talking about, and you want to know RF signal, right? So to be able to know where that is, you have to be able to find true north. And in Holly's example of being able to take a bus and put it in a community, one of those static assets, kind of like the whole reason that Uber's been popular over the last few years and Lyft has been popular is because people got away from those assets that are sitting there idle all the time that you pay for. Well, buses sit there idle all the time. So can we get greater utility out of them? By putting a bus in a neighborhood with a Wi-Fi access point, with a backhaul that could either be cellular or point to point from one Apogee to another, you're able to extend the campus network on there. And using modern batteries, you have a great deal of power, and for our equipment, it operates at very low power. It was actually designed so that it can be powered by solar. We run at about 4 watts at peak power usage. So that gets you off the campus and gets you on that bus, or maybe you're sitting there at the edge of the campus and propagating signal into the neighborhood. So out of the box, what do? We're covering 10 plus acres out of the box with an access point connected to us, and we're agnostic to the access point. We like to say we love them all. It doesn't matter if it's Meraki, Sonic Wall, Ubiquity, Ingenious, HP Aruba, any of them that are out there, any of them that you're using, we have some very minimal requirements coming from the AP. We're looking for 1 watt of RF power and external RF connectors. And then we can take that AP that's traditionally propagating a signal 150 feet and cover 10 plus acres. In fact, we put an antenna on a middle school here recently in North Texas, and out of the box we covered about 12 and a half acres just from one corner on campus from the northeast corner of this school. And if you think about that in terms of feet, it was north to south over 2,000 feet of coverage into the neighborhood, into people's front yards and actually backyards. I was lucky enough to be part of the walk testing with that, and a neighbor of the school allowed us to go into their backyard, and super strong Wi-Fi signal. That brings me to one of the next real critical features of Apogee. So for those of you that understand how Wi-Fi works, you have a transmit link and you have a receive link, and then at the other end of that, you have a client device. It could be a phone, could be a tablet, could be a laptop computer, and that's also got a Wi-Fi antenna, but it's not that strong of a Wi-Fi antenna. It operates at about 1/10 of a watt, whereas your AP is running at a watt of power. And with large-scale deployments is it's been relatively easy to push a signal out a certain distance from the AP for transmit, but on the receive side of that, the client device, the thing that actually why you need to have a Wi-Fi connection, either couldn't connect to the Wi-Fi network, or if it could see it, didn't have a usable connection. And that led us in our development to what we call asymmetric gain. And what asymmetric gain allows is we go right up to the limitations on the transmit link, the FCC limitations, and pump out 15 dBi of gain. And that gets us a long way transmit. Gain is logarithmic, and we've got a lot of power, so we can extend that signal and transmit at a really long distance. But that's not been usable in the past. What we've done on the receive link is apply what we're calling asymmetric gain, and pumping 24 dBi of gain to that client antenna. So that smartphone, that tablet, now looks and feels like it's got a high-powered antenna sitting right inside your hand. And that allows you to have a usable streaming quality connection at greater distances. Okay. We also have, things like trees get in the way. And while we can't defy the laws of physics, we do have the ability to add incremental gain in what we call foliage mode, which helps us penetrate tree canopies more efficiently by adding another 3 dBi of gain and extending the coverage and powering through some of those lighter obstructions that you'll find in an RF environment. It's a sectorized antenna that in those 4 quadrants, you have 10 antenna elements in each quadrant. 5 of them are 5 gigahertz, 5 of them are 2.4 gigahertz. And what this really means is we're covering such a vastly bigger area with RF coverage that you don't need as many AP locations. Now, please note that what I said is AP locations. We're not necessarily limiting the number of APs needed in a given deployment. If you have a high density of subscribers in a given area, the AP controls how many people can connect to it. But with Apogee, another problem that we solve for is antennas' relationships with access points have traditionally been one-to-one, one antenna, one access point. And currently we're at a 4-to-1 relationship. You can connect 4 access points to a single Apogee antenna and increase the number of concurrent sessions you can support out of a single AP location. And what that provides you is effectively a 30 to 40% reduction in cost for deploying Wi-Fi in large scale areas, because you're reducing the number of AP locations, all the cabling and all the labor, switch ports and connectivity that are needed to provide that kind of coverage area with fewer locations. Now, if we go back to the bus example, you think about a bus and say, okay, well, I might only have one AP because I'm not going to have more than 30, 40, maybe even 50 students in that nearby area. Could be 100 students. You know, that number is going to be dictated by the area and the density of the economically disadvantaged in that area. And that's fine, because what you don't want is you don't want to take a perfectly good access point that has distance limitations, put it on a bus, and require all those students in the area to go and gather around a bus where they don't have power for their laptops and they don't have power connectivity for their tablets. So they're only there for a limited amount of time. And if we're in this world where we have to manage social distancing, you don't want kids. The whole reason why you have AB days coming in the fall where 10 kids are in a classroom and the other 10 kids are working from home that day is so that you could create that separation, that distance between them. So what Apogee is going to do in that bus scenario is take that coverage that would be provided right around the bus and extend it still 10 acres, 10 plus acres in that neighborhood, so that you'll have students working from their yard, or, you know, maybe even extend from the campus into another Apogee in the neighborhood if you have a library nearby, and extend the footprint, because we do support point to point between Apogees as well as point to multi-points in the same sector. So you're able to, instead of running expensive fiber, and in some cases it'll be very reasonable to deploy the bus and get more utility out of that bus as kind of a mobile Wi-Fi cell on wheels. In some cases, you just need another place where you can mount an antenna and extend your footprint. In either of these scenarios, what you're going to find is a significant reduction in capital investment needed to extend your Wi-Fi network. And in some cases, you'll find that you have access points that you can redeploy with an Apogee that are already as part of your network. And beyond that, when you do have to make a change, take that bus as another example. The bus, you want it on 29th Street one day, and you need to move that bus for where you have a density of kids the next day and they're out of class, the other kids are in class. You move that bus to Avenue A, you have to reorient the antenna. You do that through our cloud manager. You don't have to have smart hands out there on the bus to reconfigure everything. So it makes it extremely easy to not only deploy, redeploy. And take a deep breath, because that was a lot on that slide, Holly. But you can go to the next.
It was, but it was very informative.
So here, what I want to show, and this is going to be for my fellow propeller heads out there, which I admit I am one of them, but this is an RF map of a ranch area that we've deployed in Central Texas. And what you see here is, I'll show you first the 2.4 gigahertz uplink and downlink in the coverage area, and then I'll show you the 5 gigahertz. But what you're effectively seeing here is, if you can see it on your screen, there's 3 magenta circles, and that's your Apogee AP locations. And the red area and the amber areas where you have really strong string quality signal, and that coverage area is roughly 55 acres. And that's significant all by itself with 2.4 gigahertz. But for those of you that understand some of the limitations of 5 gigahertz, and once you go higher in frequency, you lose the ability to propagate signal out as far. You lose some of the distance. So if you go to the next slide, Holly, what we're going to see is the 5 gigahertz link with Apogee is covering 80% of the same ground as the 2.4. And in a typical Wi-Fi deployment, you're going to find the inverse of that, where it's going to be 5 gigahertz would only cover roughly 20%, depending on the environment. But so we're getting great utility out of 5 gigahertz and make it usable for more than mesh and backhaul, and make it usable for actual subscriber devices, and in fact, giving you a greater amount of bandwidth and greater utility for your subscribers, or is what we're talking about today with students. So that's it on this slide. So Holly, I think you're muted.
You can't read my lips?
Try.
So, very exciting, your solution, because it really can help us close that homework gap and really find a solution that someone can deploy really quickly. Because if I understand correctly, from what I've learned, your deployment is very easy and very fast.
Yeah, we've had deployments where, once you get out on site and you put the apogee on a mast, you put it on a J bracket, however you're going to mount it, start to finish, you're looking roughly 20 minutes to get it on the network and get it configured and radiating RF patterns where you want them. So if I'm looking at, the time it takes to install and the amount of labor it takes to install, when you're the traditional way of putting an antenna on a AP or on a mast or on a pole or something, you're kind of jiggling things around and turning and then going and walking and testing and then or driving and testing, and then you're manually moving things. You've got to level out to measure tilt, and we've got a level built into it. So we're going to, at the time of installation, say, look, the tilt's off by 1/2 degree. We need to slightly bump it up here on the right. True north is 5 degrees to the left, so let's turn that thing a little bit. Okay, now we're oriented. Let's push out our signal. We want vertical, we want horizontal, or if there's a lot of tree canopies, you're going to pump out the foliage mode, and you're walking, testing, and enjoying a very robust signal over a large coverage area in a very short amount of time. Which, to me, that's the conversations I've had with superintendents and with IT leaders in schools right now. That's really important because the clock's ticking. School starts for some people in a month. Some of them it's going to be after Labor Day, and somewhere in between. And they've got solved for this right now. And it's not just the procurement side of it that you talk about and how quickly you can actually acquire the equipment. But once you do, how hard is it to install something? Do you have to go to long classes and learn for 3 days? No, not with this. We do a lot of that hand holding. It's a very intuitive user interface, but it just doesn't take a lot of time and a ton of labor to get you up and running.
Yeah, no, that's very important. And especially because we're not even sure what that new school year will look like. We might have longer breaks spread throughout the year. So it'll be really important for everyone to really know how they're going to provide that connectivity, especially in the economically challenged communities. So let's talk about funding, right? So this is a great solution. And I know everybody out there is probably going, wow, how much does it cost? It's, really expensive. And I think one of the things that you will find is that this is an investment you're making. So it's a year-over-year investment. So obviously the cost, diminishes over time. If you think about when you're buying a subscription per user, and that's a very different model, right? And there is no investment there. It's going to diminish over time, and you really get the money out of your investment there. For instance, like an air card, right? So an asset like that you're having to provide a student, your cost is going to be constant over the life of the time that you have deployed that type of a solution. Whereas you're making an investment in an antenna, a piece of equipment that is actually going to be, you're investing in that connectivity. Anything you want to add to that real quick, Jason?
Yeah, certainly. In certain cases, Wi-Fi, from a technology perspective, is a very reasonable way to solve problems, but there is a recurring cost that goes with that, and there's different flavors of that solution. Some of the lower cost ones I've seen are $20 per student per month, and I've seen upwards where you have multi-carrier Wi-Fi cards that can go upwards $50 to $60 a student a month. You start breaking that down, that's an ongoing recurring cost on a monthly or an annual basis. So if one of the school districts we've worked with that has 30,000 students and 10% of them are economically disadvantaged, if you have to put a Wi-Fi card in 3,000 students' hands, at $20 a month, you're looking at $750,000 annually. And that's just not going away. That's going to be ongoing. I know in the private world, we have some different rules than you do in the public sector, but if I'm on that school board, I want to be mindful knowing that there's a solution that has a cost horizon to it versus one where I'm going to have to constantly pay the same dollar over and over again. And if I go for the multi-carrier solution, I'm going to be spending $1.5 million a semester, $3 million a year for those 3,000 students. So, what is the cost in year one is what we've seen is typically significantly more expensive than anything that you would be doing with us and any of our partners. Beyond that, our costs go down after year one.
Right.
And those costs, I know that we'd like to say that they stay flat, but actually those costs go up year over year because you have to adjust for inflation.
Exactly. So we're talking about costs, let's talk about funding your project real quick, and then we'll get to some Q&A. So there are some really great programs that the government has actually brought to you and the community to help IT administrators, superintendents, and school boards all try to figure out how to solve this problem. And it's all basically all the infrastructure and everything that you need to have that remote learning environment, but also to make it equitable. So one of the programs that they did fund immediately in the first round of the CARES Act was the GEARS program. GEARS program basically means that it was funding that was given to the governors. Every governor of every state is going to have their own education organization that's going to be able to know how best to disperse those funds. And every state has different types of challenges, right? Whether it be topography and all that, or where you have your fiber networks built and things like that. But to getting connectivity, you could have other challenges, like you might have a state that has a lot of tribal nations, right? And so you have a lot of rural areas that you're having to work with. Even to the fact that some states, like the large states like California, for example, or Texas, that you have the big metropolitan areas. So, and that would be more of that urban type of area that needs some help. So knowing that under the first CARES Act, they created the GEARS Act. It's not as large of a bucket of money as they've given through some of the other following CARES Act releases for funding, but it is really significant. One thing I am going to do, and we're going to provide you as an attendee to this session, we're going to actually provide you all the information where you can get more ways of finding out how to go get this money, right? Where are the resources to get the money? How do I apply for it? And they've actually made them really, really easy, especially with the Paperwork Reduction Act of the government. So trying to make it much easier for everyone to get the funding without having to kill a bunch of trees. So we'll give you all that information as a follow-up. The other things I wanted you to know about, that they also have another program that you can see here on the screen where they put billions of dollars, 16 billion actually, to help you find a solution for remote learning. That's going to cover everything from your network infrastructure. It'll cover the cost for the wireless access points that you may need to deploy, say on the school bus example, or other assets you may have in the community, but also as well as paying for the Apogee. So you can actually fund this through these programs, and these are grants that you can go out there and get, and they're not like those grants that you're going to have a pile of paperwork that you're going to have to go out and work to get them. I've actually walked through the application process, so I actually know that really not that difficult, and you can go get that money now. The other cool thing is that they've released through, they listed some of the challenges that you've had on trying to solicit these types of applications or solutions you need to deploy. And what do I mean by that? In the past, in the E-rate program, if you were to work with an organization outside of the E-rate program to go ahead and maybe a gift, right? And we know the $25 rule for gifting, but say it was you needed to deploy an Apogee antenna, you would have to go through the RFP process. You would have to find a bunch of other ways to go about it. You couldn't have any of those special services that could be provided just as a part of the bundle that are free. So a lot of those rules have been lifted to help everybody get through this through September. And I believe they'll probably extend that even further. So the other thing too is you're allowed to work with organizations such as Second Gear to really solicit what do you need, right? Have them come in and evaluate what you need without having to actually go to an RFP. So the cool thing about working with an organization like Second Gear is they can help you with the tablet, the Chromebooks, whatever it is you want, or any type of laptop you need. They can help you get access to that. They sell that. They also sell this Apogee solution. They have a great solutions architect team that can come in. Another thing that they also provide, the Apogee team can also support you from an RF and really figuring out the your RF solution that you need for your community. And all of that is actually covered and paid for through all of these various programs. Another one that they did also release money for is under the library, for the libraries and museums. So think about your community and your environment. How many libraries are out there and how many museums? What if you need to put an Apogee on a pole and have it tied to the network that you have there inside that or that campus, right? So whether it be that museum or that library. So really trying to find a way to help fund you to get that out there. So all the things you need to build in your network are funded under the program. One other thing too, you can always think about, if you're worried about from a security perspective, you could actually build a redundant layer networking system just to support this type of deployment. So a lot of key things to think about that would really help you in making a really good decision. But we will make sure we get you a lot more information out there to follow up to this presentation that will come from the Second Gear organization. With that, let's bring Leslie on real quick. I bet we have some questions, and I think, Leslie, you have a couple for us as well to just kind of follow up. And so we'll turn it to our host, Leslie Zach from Second Gear.
I do. Holly, Jason, thank you very much. This is Leslie Zaks. I've been with Second Gear coming up on almost 25 years now. So I actually have a few questions for Jason first, and then a few questions for Holly. Although Jason, I think you already answered my first question on your features slide. I wanted to ask what Wi-Fi access points does Aura work with? I did notice that on your feature slide, Aura is agnostic to Wi-Fi access points. Is that correct?
We are agnostic to the manufacturer. We do have a couple of, I would call them very low hurdles to cross. We need 1 watt of RF power out of type N external RF connectors. Those are our requirements. If you have older access points that are built circa 2013 and 2014 that have external RF ports, a lot of times what you'll find is that the power that they can provide over the RF port is 250 milliwatts. So that's not going to be enough to really pump the signal through us and let us amplify it to get that 10 to 12 plus acres of coverage. So yeah, we're agnostic to the manufacturer. We just need a watt of power, RF power, and those external type N connectors.
Great, thank you. My next question, how do you cover more subscribers if you reduce the number of AP locations?
Yeah, that's something that's very important for people to understand. So like I was saying before, typically it's a one-to-one relationship between an antenna and between an access point, but with us, we can support 4 access points right now. We're looking to extend that to a greater number of APs being able to connect to a single Apogee, but the number of concurrent sessions or subscribers is a function of the access point. And to be able to, in a large scale deployment, where you have a lot of people cloistered around, 1 AP is not going to be enough. That's why they stack them on top of one another and you create the interference. By putting 4 APs off of 1, 2, 3, 4 APs off of a single Apogee, you're able to group those together in your AP software, your AP manager, where they synchronize their transmit and receive, and you're able to increase the number of concurrent sessions from a single location. And again, that's a fantastic way to reduce cost and capital expense right off the bat.
Great, thank you. Thank you. My last question, we all know that phones often times have a hard time connecting to Wi-Fi at long distances. How do you make sure that the phone, tablet, laptop can actually use the connection?
Yeah, and those were arrows in our back when we were a service provider, when we started developing Apogee. Initially we started out in marinas and pushing Wi-Fi signal out past the pier onto yachts. And we really quickly recognized that the client devices just didn't have the power to make the round trip back to the antenna and back to our APs. at the time. So that's where we came up with the concept of asynchronous gain. And on the transmit side, we push right up to the limits of what's allowable by FCC Part 15. And on the receive side, we're amplifying that signal by 24 dBi, and that amount of gain is about 100x what you typically find on a on the antenna that's coming from the client device. So it becomes usable, and often what we'll see with the upstream from the client device is at greater distances that signal is actually stronger than the downlink, and the downlink's fantastic, but you see a more synchronous type connection, or the upstream actually having greater upload speeds than download speeds. It's all about the asynchronous.
Great. Thank you, Jason. I'm going to switch over to Holly now. I have a couple of questions, then we'll open it up. Just in speaking in reference to the connectivity to the phone, tablet, laptop, are these devices covered under any of the funding programs you just discussed?
Yes, actually all of them are. So that's what's really great, is that getting access to the funds to help you deploy one of these solutions, you can go get the money today. And they're all covered.
I know you mentioned you're going to release some information, but how can our customers attain more information about attaining this funding?
Yeah, so, and we're going to make sure that everyone has the links that gets you to the source. So we're going to follow up with this call and make sure that everybody has that.
Great, thank you. I have one last question, then we'll open it up. Do you anticipate seeing any changes in the E-rate program for 2021 to be inclusive of holistic solutions for the homework app?
Yeah, that's a really great question. And it actually leads to what is coming up in 2 weeks. I'm actually going to be a guest with your Tech Talk, and we're going to actually cover the E-rate program. And I'm going to give you some insight into what's going to be new in the program. There's a lot of changes under the E-rate program, and there's going to be even more. So I believe even the eligible services list is going to change dramatically. But I'm actually on the next Tech Talk, I'm going to give you a lot of insight into the new money that everybody's going to get, some of the new rules, and really help everyone to better understand how to position what solution they'll deploy for their network moving into this new school year, and being able to utilize those E-rate funds. That's kind of a teaser, Leslie, so we'll have more information on that.
That's great. Thank you. Thanks to both of you. Eleanor, I think we can turn it over now to the group.
Yep. Yeah, so we do have a few questions. Jason, we have 2 questions for you from Michael Summers. He asks, do you have a good package solution with solar power in order to possibly put the solution on utility poles rather than buses? And then the other question is, does the solution typically do okay with users who may be inside their homes instead of outside?
Okay. So we don't have anything that we have currently that we offer as a bundle for a solar power solution, but there's a ton of solar power solutions out there. We did design Apogee with that in mind, and I can tell you our power draw at peak is 4 watts, and that's during the installation and first getting connected. That's going to be our peak power draw, and then standard operations 2 watts. So we're very low power. So that's something that possibly Second Gear can help you with, sourcing that solar power solution. As far as we're concerned, so long as we have that amount of power, we're going to be fine. The second question, can you refresh me on the second question?
The second question was, does the solution typically do okay with users who may be inside their homes instead of outside?
Well, that's a loaded gun. So we don't defy the laws of physics. What we'll tell you is we do expect some users to be able to enjoy a robust signal inside, and it's going to be dependent on distance, but there's going to be, anytime you run into a brick wall, the signal is going to be attenuated. So it's not something that we can say out of the box that we're definitely going to plow through stucco and brick and aluminum siding. We're going to still run the same laws of physics. But if you're within range and you're near the windows, you're certainly going to enjoy a better opportunity to enjoy that signal. But I can tell you that I've been in, it's kind of funny, being the marketing and strategy guy, I've been personally in backyards on the other side of the house away from the apogee with 8 trees in the way, and been able to maintain a connection with speed tests that were that had RSSI readings that were well within range, and able to still stream ESPN on my phone.
Awesome. Great. Okay. Yeah. Is there anything else you want to add to that?
No, not really. It's going to be, I guess I'll add that it's always a function of distance and what the building material is. It'll be case by case.
Got it. I think that's it for our questions. A big thanks to Holly, Jason, Leslie for today's presentation.